Dear students, today we will learn few things or few facts about data warehousing. Data warehousing is a term where the data will be collected all together and stored in a proper place for creating a workspace for a data scientist. So whenever a data is made available to the scientist, he or she can make use of it and make a generalized decisions or provide a summary of the data as and when required by the customer. So data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. It's said by W.H. Emon. So this is a characteristics of any data warehouse known as subject oriented. We say it as a subject oriented because moreover whenever we think of creating a data warehouse, we will be looking for the important terms of data like product, sale and so on. So we will have a concept in mind on what basis we are going to design the data warehouse or which thing is going to be focused for the creation of data warehouse. Integrated, so constructed and by integrating a multiple or heterogeneous data sources. Whenever we think of creating a data warehouse, we will get data from multiple sources, uh, either history or from different cell phones or PC or different data already made available data warehouse. We say that it is a heterogeneous data warehouses, and we will try to integrate them, combine them all for creating a proper data warehouse with a good dimension and good availability of the workspace. Then we have a time variant. So whenever we create a data warehouse, that will stay for a longer time for operating or processing on the data. So this will be stay for a longer time. So that's why we say this as a time variant. So this is non-volatile data. Once we create a data warehouse, it will stay for a longer time. We are not going to delete any of the data for during the processing or during the existence of data warehouse. So this is a data warehouse architecture. So this is a multi-tiered architecture. So this particular part is uh, to say a process or the different sources available. We will have a different sources. We'll collect the data from that. These sources are known as a maybe already existing data warehouse, sorry, database or the PC, machine, mobiles, etc. All these data will be loaded into data warehouse with this extract, transform, load and refresh method. So this process is known as ETL process. This is a very famous process and were widely used for creation of data warehouse. We also have a metadata that to be stored in a data warehouse, and that is further used for processing, or this is known as OLAP engine. So this OLAP engine is nothing but an online analytical processing server which process on a data or which converts the data for a freely usable by a data scientist. So this is a front end for a data scientist where he can make use of the data for a further use. So we have to understand what is ETL process. Just now we are talking about the ETL process. So this is extract, transform and load. Already we said we will be collecting data from different sources, and once we get the data from different sources, we will have to collect it all together. So this collection of data process is known as data extraction. So once we get a data from heterogeneous sources, is known as extraction process. But this data is not as per our expectation. Few data is missing. Sometimes we may get an error in the data. So we have to apply a cleaning process. So this cleaning process will remove the spaces and try to fill up the the constant values wherever no data is available. So sometimes we will try to fill up the spaces with some standard value, sometimes with the average value. So this is known as a cleaning process. The cleaning process involves making a data for a proper usage or proper uh, availability. Once we clean the data, we will go for a data transformation. When we get data from a heterogeneous or different sources, the data is not properly available. So we have to convert it into a warehouse kind of format. So general format is converted into data warehouse format with the help of data transformation method. Then we load the data into the data warehouse. So for that we will have to apply different methodologies like sorting, summarizing, consolidating, and computing views of different data sources. All these mechanism is for loading the data into data warehouse so that the data will be properly stored and will be made available for the further use. Once the data warehouse is constructed, then we will have to load the data as and when a new data is made available at the data sources. So this new data is collected from the sources, then cleaning, transformation, load process will be done, and this is known as refreshing the data. Then the data, we have to understand some facts related with data warehouse. The data warehouse is based on multidimensional data, as if we have already shown or we have discussed. The multidimensional data model which views data in the form of data cube. So as we said that this is a multidimensional data, so we have to understand it in the form of cube. So these cubes will allow us to work out for a proper analytical or analysis kind of methods. So that we'll see later. So when we say that this data, multidimensional data, is in the form of cube, then we will have to say that it includes the dimension tables and fact tables. So dimension tables will include all the dimensions of the cubes. The dimensions are nothing but the attributes that we use it for the database creation. The name of a person, brand name, brand type, and sometimes we will have the dimension in the form of time as well. This is a day, month, week, year, quarter kind of dimensions can be used. We will have more dimensions like height, weight, and etc. The currency can also be considered as a dimension. Fact table, so we have multiple dimension table, and those multiple dimension tables are connected to the fact table. So fact table includes the primary keys of the dimension table. So if we have a 10 dimension tables, then all the primary keys of these dimension tables are combined in the fact table. So finally fact table will have 10 keys each of the dimension table. So then this is the example of a cuboid which we were talking about. So it has all is the topmost value, and we have to start from the base like time, item, location, and supplier. So this combination we will get here, all these dimensions like time, item, and supplier will go in this direction, and total combination, permutation, and combination of all these dimensions will form uh, a cuboid. So this is a 4 dimension cuboid which includes time, item, location, and supplier, whereas this is 3 dimension cuboids which include three attributes, 2 dimension cuboid which includes two dimensions like time and location, whereas one dimension cuboid will have a separate like time, item, location and supplier, and the final is zero dimension where we do not have anything to as a dimension. So when we say that we are supposed to create a data warehouse, then we need to have the schemas. So the schemas, three different types of schemas are used for defining any data warehouse. The first is star schema, second is snowflake schema, third is fact constellation schema. Star schema will include one fact table and multiple dimension tables. So fact table will stay in the middle of the schema and dimension tables are connected to all around the fact table. So one fact table and multiple dimension table is a star schema, whereas snowflake schema is same as a star schema. It has one fact table and multiple dimension tables, but the dimension table is what it is normalized into smaller tables. If we have a dimension table, then this dimension table is partitioned into multiple, and that is connected to the main dimension table, and the key of that dimension table is included in the fact table. Then we have the last is fact constellation schema. So this fact constellation schema includes more than one fact table, and dimension table. This includes normalization of dimension table as well. So that is why we say this schema as a galaxy schema or a fact constellation schema. This is an example of a star schema. So as we said, we have only one fact table here and multiple dimension table. Time is a dimension, item is dimension, then we have location as a dimension, then branch is one more dimension. So if time is a dimension, then time key is included in the fact table. Item is dimension, then item key is included here in the fact table. The primary key of location is included here in the fact table, and so as all the primary keys of dimension table are included in the fact table. So we say this schema as a star schema. Then this is a snowflake schema. It is one and the same. It looks like a star schema. All the keys are included here in the fact table. So fact table includes the primary keys of all the dimension tables, but these dimension tables, let's say this item dimension table, this item dimension table is normalized here like supplier key and supplier type. One more table is created and the key of that is connected to the item table. So likewise we have a city, a location table. This location table is further normalized into a city. Then city key, city state are the attributes of this particular table, and the city key is included in the location table for connecting these two, a sub-table to the main table. So this is how the snowflake schema and fact constellation schema is this. So in the fact constellation schema, we have more than one fact table. This is one fact table known as sales fact table, and this is another fact table known as shipping fact table. So these two or maybe more than this fact tables may be included in the fact constellation schema. So this fact table has the keys of the dimension table. Here time, item, so many location and measures and branch, so many dimension tables exist. So these dimension tables are further normalized, and then this normalized fact table, the dimension table will hold the key of that into the main dimension table and the keys of this dimension table into the fact table. So this particular schema is known as a fact constellation schema for a data warehouse. Once we create a data warehouse, then we need to understand the dimensions of the data warehouse. We have this is a drop down kind of thing. We have all in total, we have Europe and North America, the regions, and then the countries of under Europe we have Germany, Spain. So this keeps on disclosing at every level to understand the view of this particular dimension. The city, we have different cities and the offices in the city. So if we go to upward direction, we'll club the dimensions all together, and if we go downwards, then this will disclose the dimensions all together to, or it will narrow down to a pinpointed location of the office. So this is how we will have to understand dimensions. This is example of a dimension known as location. So when we create a data warehouse, we will have to work on it. So for working, we have different functions made available by different tools. So these different functions are of three types. One is distributive, second is algebraic, third is holistic. So in a distributive, we have count, sum, minimum, maximum kind of data extracted with the help of these functions. If we want to find a count of sell has happened in India in 2015, then the count function will work. The sum of the rupees that a customer has utilized in a country like Nepal in the year 2000, and for the offices, like 10 offices in the country known as Nepal. So this is a summation kind of function will be used. So likewise we have multiple of them. These are just example. Algebraic, under algebraic data measures, we have average, minimum, standard deviation kind of functions available. With this we can make use of data, whatever is expected or whatever we need to extract for decision making will be done with this. For holistic, we have median, model, rank kind of functions for the data warehouse processing. This is an example of multi-dimensional data. We have month, product, region. Month is like January, February, then March, April, May, June, so on. So product is biscuits, and then pen, pencil, we have notebook, book, etc. And region is a kind of either country or a location. We have locations something like the Hyderabad, Mumbai, Pune, these kind of regions. If we want to find a product for a month of May, and the product is like biscuits, and the region is Hyderabad, then we have to look for this particular block for understanding or for getting information. So this is how we work on this, but the dimension can be very interestingly understood here. Like a year can be a dimension which can be further separated into quarter, month, day, or week and day, something like this. Region is can be understood in the dimensions like country, city, office. If we are not working on a country kind of operation, then directly a city and office can also be used. So this is how we work on the multidimensional data. This is an example of a data cube. So in the data cube, we have a quarters like quarter 1, quarter 2, quarter 3, quarter 4, and the date of according to that. The products are like TV, PC, and VCR, and these are the country. So we have this cuboid containing dimensions like country and a date, and we have product. So expected is a total annual sale of TV in USA. So we have to check the country like USA, then the TV, and the annual sale in all the quarters, something like this. This is how we will get information with the help of cube. This is a cuboid, is another example of 0 to 0 cuboid and 0 dimension cuboid. Then this is 1 dimension, which includes product, date and country. 2 dimension cuboid, which include the 2 dimensions clubbed together, like product, date, and then date and country here. And likewise we have 3D cuboid, like product, date and country. So whenever we work on a data warehouse, we will have multiple operations that to be processed on a data warehouse data. The important operations are explained here. One is roll up, the drill up, it can also be said as drill up, summarizing data by climbing up a hierarchy or by dimension reduction. So as we keep on climbing up, like if we have multiple and then we are working either going up and down, so according to that we will have to choose how many dimensions we are supposed to work on, and we can climb up according to the hierarchy. So drill down operation is reverse to the roll up operation. It has higher level summary to lower level summary, or detailed data to a introducing, or sometimes we may work on introducing new dimension as well. Slice and dice is slices if we are working on 1 dimension 1 by 3 or 1 by 4 operations. Taking a one part of the cuboid is also considered as a slice, whereas dice is like something 2 by 2 or 3 by 4 kind of dice can be clubbed together to find out the operation. Whereas pivot is visualizing, making a club of 2D or 3D operations on a particular data. We also have drill across, drill through operations. There are multiple other than this operations are also used for getting a proper information from the cuboid. This is how a huge data warehouse will look like. This is how OLAP operations can be considered on multiple of them. It will be extracted from this to multiple of them. This is a main cube. If we want to get a cuboid, sorry, the 2D or a dice operation, so this is what a dice operation is. So this is a slice operation. We will be just getting 1 dimension, a 2 by 2 operation here, known as a slice. Then out of that we will go for pivot, for working on some specific part of it. So this is a drill down operation. We will be taking care of some part of it, or few columns and few rows of it is a drill down operation. This is a drill up operation, going for a particular space in the data warehouse. This is a structure of some data warehouse or data cube. So this is how a data warehouse can be implemented and utilized for data science. Thank you.